We certainly need better biometry, and with different technologies we're getting emergent technologies which will have implications for allowing us to get better predictive results in relation to how surgery is going to be undertaken. And of these, I guess we really need to spend more time with epithelial mapping, because a lot of clinics don't use epithelial mapping, and it's becoming increasingly important that they do. Wavefront, various types, all of them pretty good, but I think what we're really going to see a big movement in is collation of data and the introduction of artificial intelligence to give us truly objective measurements and get rid of the errors of subjective analysis of refraction. I think that's very important. So technology is going to have a huge impact in future. Well, it's going to happen because as we digitize information, we will have more and more sophisticated systems for producing the primary information, and then we need methods of analyzing that data, and that's where the artificial intelligence comes in. With neural networks and other systems, we will end up with some far more predictive group data. And because of the way various countries are looking at regulatory changes, we will have much, much bigger databases across clinics and across clinicians. So we're all looking forward to that. The developments that will expand the limits of LASIK are really many. We're beginning to see, for example, cross-linking subsequent to LASIK procedures, and from at least one clinic in Singapore we've seen corrections go from -10 up to -20 with really good stability at 2 years. And now there are a number of large trials beginning to look at so-called LASIK extra. So that's one area. Another area is really concerned with the way the lasers are themselves being designed. Now at the moment we have problems with ultraviolet lasers, because ultraviolet lasers give problems in terms of penetrating the epithelium. But there are now ways of actually counteracting that. So if we have an ultraviolet plasma to produce our changes deep in the stroma, we will be far, far more accurate. So that's another way that things are moving. And then I guess finally we are already beginning to look at 2-photon systems which change the refractive index at set layers in the cornea. So there's a lot of technology that's going to have a huge impact. Well, the issue isn't really spot size and repetition rate, it's really the problems of potential crosstalk between pulses. So most of the companies now have actually changed their algorithms so that successive pulses don't fall anywhere near each other. So we're not getting crosstalk or thermal changes. We are now beginning to see the advent of helical electrodes, so much smoother design of laser cavities, and we are seeing movement towards much more reliability of these systems. The solid state ultraviolet systems were a little bit disappointing, but again they are becoming to the forefront because of their importance in terms of military and space technology. So that's another area to watch. I think the most important things in terms of laser development over the last few years has been a better understanding of the interactive mechanisms between the ablation process and the tissue, and that's led to much much better algorithms. If you think at the very beginning, we were doing straight spherical corrections and that was it. And then Zanicki polynomials sort of reared their head, and then we saw wavefront, and then we saw the advent of biomechanically induced changes, etc. So it's a fundamental understanding of the interaction between the lasers and the tissue that's been the big improvement. Lasers themselves have not moved very much in the clinic, but they are moving really rapidly now in the research institutions and deep within companies. But of course, nobody wants to talk about the 6th, 7th and 8th generation system because they've got to sell the present systems. Changes in the way in which we do laser procedures has significantly reduced the common problems of early systems. So the number of patients that complain of glare or halos has gone down significantly. You will always get some unexpected phenomena relating to the wound healing processes, but we are minimizing these, and we are introducing pharmaceuticals and other elements to actually facilitate the wound healing in a predictable fashion. And one of the areas that I've become very interested in recently is the whole business of genetic control of wound healing and tissue interactions. And I think personalized medicine is going to have a big future. The really big movement in terms of corneal ectasia really falls down into two areas. One, the potential over the next year or so of really good biomechanical measuring devices. So that's going to give objective measurements in the clinic. But I think more importantly, we have now the ability to detect genes which have effects on biomechanics. In the first instance, 5 genes which are very easy to detect, which govern the granular dystrophies of the cornea. More complex, we now have a number of genes which govern keratoconus, and that hunt for the keratoconic genes has highlighted a number of genes which may be involved in biomechanics. So we will have a situation, I think, in the very near future where prior to refractive surgery, patients will undergo a buccal swab that will be analysed, their gene profile will be defined as it relates to refractive surgery, and that will really reduce the number of potential complications very much more in the future. If you are buying a system, it's very difficult today because there's not a lot to choose between the systems. They're all pretty good now.